Just to introduce us again, so we're SAAS, we're a data science and machine learning club at Berkeley, and we're just going to give a final presentation for our deliverable. And what we'll go into is kind of just like an overview of like the project, and then uh, what we actually implemented in our pipeline and some limitations at the end. So to start off introducing our team, I'm Brody. I'm a PM. I'm a sophomore, currently studying data science.
I'm Akhil. I'm the other PM. I'm also a sophomore studying EECS.
Yeah, I'm Ayush. I'm a freshman studying EECS and I'm a consultant.
I'm
Yeah,
Colin. Sorry. My name is Colin. I'm a junior and I'm studying data science and economics.
Oh, I'm Dom. I'm a junior doing data science and applied math.
Hi, my name is Mahi. I am a sophomore studying data science, and I'm also one of the consultants on this project.
Hi, I'm Matthew. I'm a sophomore and I'm studying EECS.
and I don't think Niranjana is able to make it today. So, yeah. Okay, I guess, yeah, Brody, you can take it away.
Yeah. So just to go into the overview of the like objective. So uh, we were given to develop like a method to take specific political articles from a country, and some like additional information about that country, and produce some sort of like risk score, targeting specific countries that actually have elections coming up. So that was like the overall objective that we were given.
And so here's like kind of just an overview of the pipeline, just a very abstracted version. So we have a country and we gather its political articles as well as general country data. And for the articles specifically, we do some sentiment analysis as well as event clustering in order to generate more data, which we can feed into a model, which will then predict the risk level. And that's a very basic overview of the pipeline. Um, and I'll pass it on to the rest of the team to talk a bit more in depth about everything. Colin.
Yeah, can you go to the next slide?
Yeah.
Yeah. Okay. So sort of going into it at a broader level, of course, we have SARGE as our existing system for scoring election-related civil unrest risk worldwide. So important attributes here. We track all nationwide elections worldwide and update on a pretty regular basis. In order to actually calculate the SARGE metric, we combine the impact score, how much would essentially unrest be effective, how the extent of it, how much it would disrupt operations, as well as the likelihood score, which is more of a probabilistic measure, into the overall risk score. So we have the formula for that as seen on the slide. We result with a 5-category output. So we have this relatively intuitive increasing scale here. And of course, high or very high ratings directly trigger intervention. So as previously mentioned, we derive this from the impact score and the likelihood score. And if you go to the next slide, we have an example of sort of what that would look like. So you'll note that for each of these countries seen here, of particular interest, if you look at the impact and likelihood metrics, these are folded into the overall risk score metric, which contributes to our final determination in the final risk column, which we have our 5-category classification, which leads to intervention if needed. And I'll pass it off to Dom now to talk about automation.
Yeah, so can we automate data extraction? And what parts of the risk pipeline can be automated now, and what still depends on manual internal inputs? So for the parts that we can automate now, we can do election metadata and schedules, conflict and violence indicators, governance and democracy indicators, humanitarian severity, displacement and funding context, IFRC operations footprint, where public endpoints exist, and for parts that still depend on manual or internal inputs, that would be national society, readiness/strength, analyst reviewed risk adjustments, override nodes, and quantitative reasoning. So the main takeaway is that the pipeline can automate much of the quantitative background, but final operational risk assessment still depends on a smaller set of internal and analyst reviewed inputs.
Yeah, so one of the main sources of information we try to incorporate into our pipeline were just like online articles. So specifically, we want to extract information from these articles about our target country to get an idea of like the recent events that have transpired to give us contextualization on the current state of that country. So to get this online information, there were two main approaches that we were thinking of. So one of them was web scraping, and the other one was using an API. But for web scraping, it takes significantly longer to get the information, and there are some other issues like permissions for certain websites. Because of that, we lean towards using an API. So how the API works is that it has a database of articles, and we send it a query which contains information like keywords, the time frame we want to look for, the source country for the articles, and other metadata, so that the API has a better understanding of what we're looking for. It can give us relevant articles, and then it outputs these articles in this JSON format, which is pictured below. So here includes information like the article ID within the database, the title, the text of the article, the URL, and other media like images and videos contained on like that web page, if there are any. Next slide. So there were three APIs that we used to get the articles. So World News API, News in GDOT. There were some issues we had with using the API though, because the main approach that the API uses to figure out which articles are most relevant to what we want is by finding the number of occurrences of the keywords we use in our prompt, not evaluating based off the semantic meaning of the text in the article. So the solution that we tried using was fine-tuning our prompt to include as many, I guess, political keywords. And then another issue was that for countries where English is not the native language, we had to translate those keywords before we can make the query. And sometimes words in the English language don't have direct translations in other languages. However, regardless, it worked well with countries where English was the main language. And now that we have these articles, we need to actually extract valuable information about current events. So we used event clustering. So the idea behind event clustering, certain events or current events that are mentioned in multiple of these relevant articles, because they're more likely to have a significant impact on the country's current state. So what we do first is we chunk the articles into paragraphs. So minimum of 80 characters, and bigger chunks allow for better clustering. And then we embed these chunks using a text embedding model. And this allows us to perform cosine similarity comparison. Basically, like this is a computational method that allows us to like compare how related certain sections or pieces of text are. We use HDB scan to cluster these embeddings together, and then we use a large CNN to summarize what each of these clusters are about, and then we classify each cluster into 10 different sub-events based off the event that we see from the summary using a Nilly Mini M2 model. So this is an example of the clustering. So here we have an article where the title is Artificial Intelligence and Electoral Integrity. And this is a little excerpt from that article. So yeah, it's talking about how AI is reshaping political communication, voter perception, and even electoral outcomes. So as you can see on the right, these events that we try to classify each event for each cluster into, and we see like the scores or probabilities that the model thinks each event is each type of sub-event. And here, the sub-event it gets classified as is electoral process or administration interference. So yeah, the cluster has the scores, article IDs for the articles within the cluster, and summaries about what the event is about.
Yeah, so now I'm going to be going into the libraries that we use to handle the sentiment analysis portion of this project. So we use TextBlob and the Vader libraries. TextBlob is a general NLP library that uses rule-based and pattern-based sentiment, and it outputs both subjectivity and polarity. And subjectivity ranges from 0 to 1, where 0 indicates an object statement and 1 is subjective. And in this project, we're saying that 0 is factual reporting, whereas a 1 is more opinionated reporting. And Vader, which stands for Valence Aware Dictionary for Sentiment Reasoning, is designed primarily for shorter texts, and it handles like caps and emoticons, which means that it's more robust than TextBlob, and it outputs a compound score from -1 to 1. Next slide, please. Yeah, so on this slide, we have an example output from Vader, which is our main sentiment model. For every article that we call from the API, Vader gives us a compound sentiment score along with the negative, positive, and neutral proportions. We then aggregate these into features like sentiment ratio and variance. And these features allow us to capture patterns of how negative the news is overall and whether or not there are signs of violence or instability. Next slide, please. And here is an output from the TextBlob library, which we primarily used for subjectivity. Vader tells us whether something is positive or negative, whereas TextBlob will tell us how opinion-based or factual the language within the article is. A higher subjectivity score means that the article is more opinion-driven, which can usually signal bias. We then summarize this to get a sense of how subjective the media coverage is during an election. I'll now be passing it off to Ayush to talk more about the modeling.
Yeah, so we'll be going to the modeling. We tried running like a spoke test to understand if we can really predict like the likelihood and impact to then create like this predicted risk category based on the information we have from the data. So the overall flow is as follows. We start with the raw election data. We do some feature engineering. A lot of the data was somewhat noisy or missing. So we wanted to make sure that the data is clean, as well as not having direct correlations to the risk category. So we remove some of the information that would have a direct relationship to that risk category. And then we want to split this into two tasks. The two tasks are predicting the likelihood as well as predicting the impact. And once we're able to predict both of those, we're able to create the combined risk score to like kind of categorize into the risk category. So yeah, next slide. Yeah, so as I mentioned, we want to have these two separate prediction tasks. And this overall mirrors like the SARGE framework. Obviously, we have the likelihood and impact, and the way that we calculate risk is through the square root of the product of those two values. And overall, we want to understand how exactly we're predicting likelihood and impact. And we know that likelihood is generally driven by political conditions, democratic quality, historical violence, and so on, while impact is driven more by humanitarian conditions and so we want to use those factors and make sure that the data encompasses all of those qualities so that we can actually predict those well. So just for the overall model design, we have several inputs, including the stuff we need to try to predict likelihood and impact, including governance and democracy indicators. There was an example data above where there was stuff like government type, but we have a lot more of those types of features to be able to predict the likelihood and impact based on those. We also have historical violence and conflict patterns, humanitarian severity and displacement indicators, the IFRC operational footprint, and then overall just the engineered burden, funding, and per capita features for the country. And then the structure, this is more technical, but for the likelihood score model, we have what's called a random forest regressor. For the impact score model, we have an extra trees regressor, and then the direct score risk score model is a gradient boosting regressor. But overall, we have 3 different models, 2 of which are the likelihood and impact prediction models. And we also have a direct risk score model because we want to compare the results of directly predicting risk rather than kind of isolating likelihood and impact and then like calculating the risk from that. So we'll see the final output formula to be the final score being a combination of those 2 results. So we have the square root of the predicted impact times the predicted likelihood as around 75% of our final score output, as well as 25% of the direct predicted risk score, just to kind of balance out the results of predicting directly versus isolating likelihood and impact. And yeah, overall, we're trying to predict like the quantitative score. So you'll see here that the results of the likelihood score, impact score, and direct risk score are shown. You'll see that likelihood score has an R squared of 0.71, impact score has an R squared of 0.33, and direct risk score has an R squared of 0.67. And you'll see that the likelihood score in this case is performing much better than the impact score. And we can likely explain this because there's a lot of, I guess, variation in terms of predicting impact based on the features we have. So basically, the data we're using is very useful for predicting likelihood, but some of the data that we have is not very well encompassed to predict impact score. A lot of the data which we had, the missing variables were mainly impacting the impact score. So with more data and using like API-based data that we were working on, we'd be able to improve the impact score. And then overall, though, our accuracy was not bad even with the poor impact score results. We had an accuracy of around 66% and a macro F1, which is more balanced accuracy to determine like if it's actually predicting each category as equally rather than just predicting one big category. So the macro F1 was also pretty good at 62% for predicting one of the 5 categories. And generally, the errors came from predicting like the category right next to it. So if you were trying to predict something like very high, it would just say high, which is still a pretty good result.
Yeah. However, our pipeline, of course, did have some limitations, which we did talk about a little bit, but I'll just go a little bit more in depth into them. So first off, in the article retrieval and information collection, I think this was one of the kind of main limitations in that it was very hard to find articles that specifically match what we're looking for because the APIs were just based on like keywords and stuff. And we couldn't really find any which were just targeting like political articles and stuff. And countries can also have like more or less media coverage, and that can like kind of change how easy information collection is. And also because it's in different languages, the meaning can kind of get lost in translation between the 2 languages that we're translating between. And so I think a more suitable approach would be like kind of per country, although we were working on a more general solution. And in terms of data quality, we did get like duplicate articles about the same event. We got some irrelevant articles, and like, you know, translation introduced noise. So it's very similar to the article retrieval like limitations. In terms of the model fit, for like sentiment analysis, Vader was kind of designed for social media, not like formal news writing. And so it's a little bit different in terms of language, and so it's like a little bit inaccurate in that way. The BERT sentiment model was also fine-tuned on movie reviews and not election news, and so in the same way, this is a little bit off in its predictions. And word-to-vec embeddings are like they're basically trained from scratch on only about 30 articles per election, and that's like way too small of a corpus to get like meaningful word relationships. And so it's basically just mostly about the data and like there being a skew and us not having enough data when it comes to articles. And in terms of feature validity, the features don't like reliably separate high from low risk. For example, like Germany's disinformation and threat scores came out like higher than Venezuela's in our test run, which is like the reverse of what it was in that ground truth. And there's also no temporal signal in our model right now. So like all of the pre-election, election day, and post-election articles are all pooled together. So because we couldn't really find a reliable way to separate them out. And we also don't have like validation against SARGE ground truth labels, and so we don't know like which features have real predictive power right now. But overall, the model performed relatively well despite all of these limitations. Yeah, that's the end of our presentation. Thank you, and do you guys have any questions?
Terrific, thanks so much. Yeah, I think just a general question. Like, what was the biggest challenge for the team over the last couple months you've been working on this? Could be related to just forming a team, the work itself, something else. Love to know.
I think that like one of the main challenges came with like the data. I think that like getting the SARGE data was very helpful, and but like the articles were very hard to find. As you saw, we went through like a couple of different APIs, and they all had their own problems. And just like trying to find one which kind of works was honestly really hard, a lot harder than we were expecting. And so that was kind of came out as a final limitation, even though we spent a while on it. Yeah.
Yeah, Vincent, what do you think?
Yeah, thanks. Sorry, I'm raising my hand because in 10 minutes I'll have to go grab my train. So I want to sneak in a couple of things, but so no. First of all, I think that the presentation is fantastic. So it's super clear, super structured, very well documented, and I think it took a quite complex challenge. And but yeah, but you can really see the hard work, the thinking behind. So really, yeah, excellent work. Compliments. I really hope that that the same feedback you will receive it from your university counterparts on this, because I think it deserves it. So first of all, that's really great. You should be proud of the work you did.
Thank you.
To me, and I'm very satisfied. I'm very satisfied. Of course, I'm very satisfied in the sense that especially the slide, the limitation, etc. I think this is gold, no, because this is really where okay, you can point, you are able to highlight all the pain points that we around this, and it's also an excellent stepping stone to eventually to move further, right? To not just give up. Okay, well, what are the next things we can do? And thanks to this, we already have this great stepping stone. It's also it's also a very useful mirror to see ourselves, what actually SARGE is and the kind of flaws, or if you want, a weak point or blind side that this methodology still has, right? And that then this is coming up, and the meaning that can lost in translation, so the difficulty in native language versus not native language. So the data availability part is a key point, which we find a way to address through assumptions and uncertainty management, but still it's very interesting to look at also the model fit. That's super interesting. It's really valid, but also the feature validity. I think this is where probably from also a design phase, a design aspect we need to look into, right? It's very interesting that you have German disinformation and threat score coming out higher than Venezuela. I cannot say in absolute that is wrong. It's just that for the purpose of the action that we need to trigger after, then maybe it's less relevant. But no, not necessarily wrong per se. The temporal signal, yeah, that's excellent. This is really kind of a key issue there that is still unresolved in the academic literature. And also the ground truth labels, and that's on us. This is where we really needed to work. So now, to me, this is all makes a lot of sense. I would be curious if you have because can you go back a couple of slides? But I don't think I saw your final ranking. Do you have a final ranking somewhere? No.
A final ranking of like risk scores.
Yeah, I just for the sake of, it'd be fun to see at one point. Right? Okay, well, what you get. It's I'm very curious. It's an intellectual curiosity. Maybe the next, what would be interesting is also to see if we've done maybe what could be the next step. So how can we access this? How can we eventually follow up with additional question? And if you have some mental bandwidth, maybe to receive your recommendation, like, hey, lads, guys, do this, right? Consider if you want really this problem to be solved through this approach, then in our opinion, you should address priority 1, 2, 3. You should fix these 3 things. And then we can give it a new go. Not you, but someone else or something like that. It will be very interesting to get your honest opinion and your honest prioritization of what needs to be fixed so that this becomes possible and useful. But again, that's really excellent. Yeah, very good job.
Yeah, we can send all of that information after the meeting, just via email. Yeah. We're also gonna like just work on cleaning up the code base for like final submission, and then we'll just hand that over to you. We just have all of our code in GitHub, so we'll just like clean it up and then send it over.
It's great. Dagen, do you have any follow-up? I mean, you're stepping a bit at the end, but because you also know very well the project and the night that comes out of it.
Yeah. Well, first of all, wanted to thank the SAAS team for the presentation. Maybe just very briefly to introduce myself. I'm working as a risk analyst for the Africa region part-time, but also supporting Vincent's team and the global IM team of IFRC with different projects such as the risk analysis, but also the SARGE project, which I follow up for the last few months. And I have to say that this presentation was really interesting, and there's a lot of things that will facilitate our life, particularly in terms of how certain things will be automated, and it's just a lot of time saving for us. I think what I also really admired is also the fact that, as Vincent said, the fact that you were quite clear with, the limitations of this project, because it's really going to help us in identifying, what we can do and what we still have to improve, moving forward with the SARGE analysis. I think I was also quite interested in knowing a little bit, the different likelihood scores and impact scores. You know, you're giving a little bit the R square and the mean absolute error score there. I was maybe also interested to see how much of a deviation there was, whether the models tended to predict like high impacts and actually would tend to be like actually lower impacts, or whether there were more errors towards, you know, predicting something that would be like of a low impact but ended up being a higher impact. So yeah, just maybe wanted to see a little bit of more on that detail. So I would be very interested on my side to also see a little bit more this analysis and trying to understand as well, you know, how the model performed for the different countries you assessed. But otherwise, yeah, great job, guys. I really liked this presentation, and I really liked what you guys did for this project. Thank you very much.
Yeah, sounds great. Thank you.
Great, thanks. I know, Vincent, you're got to run, but do you have any last question or comment? Maybe Art.
No, no, but can I reserve the right to eventually send a couple of questions by email? That would be great.
Yeah, of course, of course.
Yeah, I know the team is going into final exams next week, so they might be delayed in responding if it's in the next couple of days, but George, I see you have your hand raised.
Yeah. Yeah. Thank you, Dan, and maybe a little bit of my introduction. My name is Kiragu George. I support as the regional IAM coordinator for the Sudan crisis, based in Nairobi right now. For me, yeah, number one, this is really interesting. Just I haven't been much involved into this, so it was really interesting. Just seeing the results and how the project is running and what it's all about. However, maybe I missed it, but just one question. Was there, like, let's say, a scenario whereby there was an assessment of, let's say, articles looking at actual, let's say, hind data of what had been published, let's say, articles before, let's say, a general election, and then the election happened, and looking at the likelihood and what just vis-a-vis the actual happening and actual articles that were written during that phase.
Yeah, I think we discussed this as one of the main limitations, like with the temporal signal. I think this is what you're talking about. Feel free to correct me if I'm wrong. But basically, because we had that limitation of our API of choice only being able to see for the past 30 days, we didn't have much data to go off of. And so we couldn't really like discriminate between like pre-election, election day, and post-election. I definitely think that like one of the main one of the main things to improve this a lot would be just to find a better way to source articles, because that way we'd get a lot more information from that, and you could actually like specifically sort by pre-election so that it's more representative of when you're actually using the model. Yeah, I think this is just one of the main limitations from our API. Does that answer your question?
Yeah. Well, I think it's yeah, it answers it. However, I'm just looking through let's say different scenarios apart from I know you had mentioned about web scraping and use of API of which you were looking at. However, in some certain contexts, I'm just thinking through how would it work, let's say, if there are news platforms. If I can give an example, let's say there is the New York Post, the Guardian, and they all post different articles. Does it mean, I'm just thinking through the process. Does it mean going through these websites and trying to collect as much of the articles there are as possible? Or is it is the model as part of the iteration will look through, let's say, the open internet on what are some of the articles there are about, let's say, a certain country and an upcoming elections and the kind of.
Yeah. I think that we chose to go with the API route because web scraping is a little bit more difficult and it runs into things like paywalls and all that. Like a lot of websites don't want you web scraping them as well. So to bypass that, we kind of went with the API approach, which basically just I don't know, Matthew, if you want to talk about this a little bit more, like what the API returns and stuff. Yeah, I guess Matthew, do you want to go more in depth into that? Because
Sure. Yeah, I think the way like you summarize the pros and cons very well. There's basically like how web scraping would work is like the idea is you start like from one website and then you scrape the information off that website and then you follow the links on that website to like other news outlets and articles, and then you continue to do stuff like that. But there can be a lot of issues, like Akil said, with like permissions, and a lot of these websites don't want you like scraping that information and using those types of technologies. So there's a lot of issues with that. Also, like web scraping, the output is not like very nicely formatted. Like using the API, there'd be a lot of pre-processing we'd have to do to get the actual information. So I guess like web scraping, there could be it could bypass like that limitation with like the time frame and all that, but with like the time we had, we just decided that using an API would be a more practical approach to getting the information. I don't know if that makes sense or if you want me to clarify anything about that.
Yeah, sounds good. Thank you.
Thanks, everyone. Yeah, just to reiterate, thank you so much for investing the time and effort to work on this for American Red Cross and for Federation. As Vincent said, this has helped them evolve their thinking about this problem, better understand the problem space, and given them some ideas for how to move forward. And I'm sure he's looking forward to reading kind of any summary documents and other materials that you send his way in the coming weeks.